So hey guys, welcome back to my channel. Hope you're doing extremely well. So it's our day 20 of solving GFG POTDs. Okay, so today's problem is known as find element occurring once when all other are present thrice. So let's see what does the problem say. So you have been given an array. You have an array, alright. And in that array, all the elements are present three times. Exactly three times. Except for one element which is present one time. Okay, you have to report the value of this element which is present only one time. Okay, so let us come to some conclusion with this example. If it is present, each element is present three times and one element is present one time. So let me assume there are k elements present three times and one element present at one time. Okay, so what will be the size of the array in that case? It would be 3k plus 1, right? All right. This is our conclusion number one. Okay. So before moving to the efficient algorithm, let's do the brute force approach first. The brute force approach would be use a map to find the count of each number in the array. What would be the time complexity of this? It would be O of n. To traverse the array and put it into the map, and space complexity would be O of n, as we are using an extra map. Okay. Another approach can be use a sorting algorithm. How? Sort the array and then if for some I arri is not equals to arr of I minus 1 and arr of I is not equals to arr of I plus 1, in that case your answer would be arr of I. Okay, clearly understood, no worries. What is the time complexity of this? It would be time to sort, that is O of n log n, and the space complexity would be O of 1. Now the main question is, can we do it in the better time complexity? Can we do it more efficiently? The answer to that is yes. But how? Alright. Please play your utmost focus here, because the things are going to get complicated here. The problem has been given as a part of a medium type, but I surely feel that it is nevertheless the hard type. So what we are doing is, suppose the array given to us is 1, 10, 1, 1. I am saying I am trying to keep two variables for my answer, that is 1 and 2. Okay. 1 contains numbers occurring one time. Okay. And 2 contains numbers occurring 2 times. And I'm keeping the third variable as common, which contains numbers occurring 3 times. Alright. So what I'm saying is, for this example test case, 1 would be initially 0, 2 would be initially 0, and common would be initially 0. Okay. When we move to this element, that is 1, we mark it as 1 here. 2 and common will remain same. We move to this. 10 also came first time, so 10 will come here with this. Move further, 1. Now, when I counter 1, I see that 1 already has 1. So I make it 0 here, and 2 becomes 2 carries 1 in the answer. I come here, I see that 2 is carrying 1. So what I do, I make it 0 here, and common takes 1. Okay. So at last, I see that 1 contains 10. So that would be my answer. Now the thing is, it looks very simple right now, but you don't have to use this extra space of carrying the elements like this. So for that, we will use as our helper function, that is bitwise manipulation. Yeah, a field which scares most of the programmers. But you don't have to worry about it. I will handle it for you. What we are doing is, don't try to complicate the things up, right? Because the question is very complicated. So just stay focused. Like in recursion, what do we say? We just think of the sub problem we are going to dive into. We don't think of the all the problems, otherwise we will get so confused. Likewise, stay here with me and focus on the smallest problem you can solve. So suppose you have the array 1, 10, 1, 1. Okay. Let me write it as here as a bit configuration. What would it be? 1, 1, 0, 1, 0, 1, 1. Okay. I had 1 and 2 and a common. All of them are 0, 0, 0 right away. Alright. I come at this index, that is 1. I encounter 1. Now, to check whether it is in 1, whether it is in 2, whether it is in common, what can I do? I will do that. Uh, what can I say? Yeah, I will say what I'm doing is, suppose you have an array of this bitwise. Okay, let me make the count. So if I see, I can see the maximum number of bits are 4. Okay, if I see the LSB, that the first bit from the left, from the right, sorry, how many counts of 1 are there? So I see 1, 1, 0, 1, 1. So I see 3 counts. All right. Now for this bit, the second was from the right, only 1 count, and then this one 0 count, and then this one 1 count. Can I say the numbers, the bits who have a set bits count of 3n plus 1 would be 1 in case of the final answer? Only those bits who have a type of 3n plus 1 in the counting of set bits will have a 1 in the final answer, because we discussed above that 3k plus 1 was the format of the array given to us, size of the array format. So now if a number contributes 1 to a 1 to a count of the set bit at a particular position, then it will and if it is occurring 3 times, then it will automatically contribute 3 times to it. And now if one number is contributing only 1 time, which is our answer, it will contribute only 1 time. So every number who has a set bit count of 3n plus 1 form will have a set bit in the final answer. So like, as I can see, 3 is not of the form 3n plus 1, so it would be 0 here. 1 is of the form 3n plus 1, where n is 0, so it would be 1, 0 again, 1. A final answer would have a configuration of 1 0 1 0, which is 10. This is the final answer. Okay, let's move on to the dry run of the program, how we are going to handle it. So now let's dry run it. How we are going to able to do it? Suppose we have 1, 10, 1, 1. Okay. We have 1 as 0 initially, 2 as 0 initially, common as 0 initially. Okay. Now I want to update 2. Our first step was updating 2 if 1 already have that element. Alright. Our first step was update 2 if 1 already have that element. Now instead of element, I will say set bit at that position. How we are going to handle it? So suppose we have a 2. What can we do so that 2 becomes set at that position if 1 was already set? 2 becomes set at the position if 1 was already set. This is a star pointer. Okay. 2 becomes set at the position if 1 was already set. We have to update 2 if and only if 1 was set at the position. Okay. So we cannot, if 2 is set at a position, we cannot decrement it. We just have to check if 2 is 0 and 1 is 1 at a position, then we have to update it. So how can we do that? For that, 2 becomes 2 or because we are using or operator because we do not have to decrement the set bits of the 2, we just have to increment the unset bit of the 2 if the condition is valid. Now here it will come if one was already set, like suppose we have this as a configuration of 1 and this as a configuration of ARRI. Okay, when will this bit move to 2? This bit will only move to 2 if x is also 1. If x is 0, we do not have to move this to 2. If x is 1, we have to move this to 2. For 1 and 1, this what could be the operation? It would be AND. For 1 and 0, it will give 0, and for 1 and 1, it will give 1. So what we are doing here is 1 and ARR of I. Okay, this was our first step. Okay. What is the second step? Our second step is to update 1. How we are going to update? We are going to unset the set bits of 1 if the new element is also set at that corresponding position. What I am saying, suppose this is a configuration of 1, okay, and this is a configuration of, let me remove this mark, yeah, and this is a configuration of the new element, that is ARR of I. This is our 1 and this is ARR of I. When are we going to unset it? Just think. We are going to unset it if this is also 1. That means the occurrence of this was 1, correct? If the occurrence of this is also 1, its occurrence become 2, okay? When its occurrence become 2, we have to remove it from 1 and move it to 2. That is, remove it from 1 and move it to 2, correct? I think I'm making a clear statement in your minds, okay? If you have any doubt, just drop the timestamp and write your doubt. I will surely get back to you, okay? Remove from 2, remove from 1 and move it to 2. Alright. But if x is 0 here and y is 1 is 0 here, what to do in that case? So x is 0 here, x is 1 here, but 1 is 0 here. What do we have to do in that case? In that case, it means that 1 does not have any initial, what do we say, increment. It has come first time or third time. First time or third time, correct? We cannot predict that. We will be able to predict it with the help of common only. For now, just treat it as first time. So in case of 0 1, we have to change it to 1, and in case of 1 1, we have to change it to 0. Are you able to connect where I'm going with this? I'm going with towards the XOR operator. Remember, is it in the configuration of the XOR, truth table of the XOR? correct? So what step I'm taking? I'm saying that in the second step, 1 will become equals to 1 XOR of ARR I. Okay. Coming to the third step, that is updating our common. Now, as you remember, common was an element that consisted of both 1 and 2. That is, if common contains element. Now, whenever I say element, just think of set bit. Okay, contains element occurring thrice. Okay, occurring thrice. We have to handle occurring thrice. Can I say occurring thrice means 1 plus 2? Because 2 said 2 times, 1 said 1 time. So 1 plus 2 gives 3. So if we take an AND off and of 1 and 2, we will get the common set bits and the common will be in our hand. So what will we doing in the third step? This is the most easy step, I guess. Common equals to 1 and 2. Alright, this is the third step. Now we have got a common. Okay, so think of a task that what did we do for the example test case? We said 1 2 common. We had 1 10 1 1. Okay, first we moved 1 here, then we moved 10 here, then we moved 1. When we checked it was existing in the 1, so we cut it down from here, move to 1. Okay, we have handled this part up till now. Now we come here and we check that it was existing in 2, so we cut it down from here and then come to common. So when our common was getting updated, our 1 and 2 were getting actually cut. So what are we doing is, if our common set bit is common bit is 1, then it has to be 0 in both 1 and 2, correct? If it was 1 here, it was 0 here and here. What we are doing, so now what we have to do, we have to update R1 and 2. How can we do that? So what do we have to do? We have suppose this is our 1, okay, and this is our common. Okay, if this is our 1 and this is our common, and we have to say if this is 1, make it 0. Okay, if this is 0, no values, no matter what can we do, we don't have to do anything. Okay, so what can we do? We will first note it, that is change this one to 0. Okay, now take an AND. Suppose I'm turning this one becomes 0, this one will become 1. 1 and 0 will become 0, 1 and 1 will become 1. So if it was 0, it remained 1. If it was 1, it changed to 0, which was our prime objective. So what are we doing is 1 will change to, this is the final step, 1 will change to 1 and tilde of common, and 2 will change to 2 and tilde of 2. I hope I am very clear right now. I don't think I have left any doubts. Okay, let me add the pseudocode once and for all in a proper format, and then we will analyze what we are doing. Okay, so let me change the ink. Yeah, what we were doing is we initialize 1 as 0. Okay, 2 as 0. Okay, and a common. We didn't initialize common. Okay, now for int I going from 0 up till n minus 1, our first step was to update our 2 if it is already existing in 1. 2 equals to 2 or 1 and ARR of I. Okay. Then update our 1. 1 equals to 1 XOR of ARR of I. Okay. Then common equals to, if it is existing in 2 as well as 1, 2 and 1. Okay. Okay. Update our 1 and 2. So 1 would become 1 and common. Similarly, 2 would become 2 and common. Okay. After this loop will end. Now this is my question to you. What would we return? Would we return one? Would we return two? Or would we return common? So what? Let me change the ink. Oh, sorry. Yeah. What would we return? Options are option A, 1, option B, 2, option C, common, or option D, bitwise combination of 1, 2, and common. I'm giving you 10 seconds. First, comment your answers below, okay? That wise, I will also be able to recognize how many of you have actually understand the code, okay? So, our options are 1, 2, common, and bitwise combination of common. Okay. What did we study about them? We studied that 1 contain count of 1, 2 contain count of 2, common contain count of 3. Okay. What if I multiply them with, what if I add 3k to them? Okay. Add it down. 3k, 3k, 3k. This can be named as 3k plus 1. That is multiple of 3. This can be named as 3k plus 2. Okay. This can be named as 3k plus 1. Okay. So what would be my answer? My answer would be 1 because we needed the form of 3k plus 1. The one element will be the answer. Okay. What if, what if we were asked uh, about the combination of the two elements? Suppose the question given to us would be that all the elements are present 3 times and two elements are present one single time, or one element is present 2 times. In that case, 2 would contain an answer. Okay. Okay. If you have any doubts, please comment down. If you have any suggestions, please comment down. Okay. This was our approach understanding. Time complexity is often because we are running only single time, and as you can all can see, we are just using variables to store some values. We are not using any extra space, so space complexity is also O(1). This is the most efficient solution. So without wasting any time, let's come down to the code. Okay. So while coding, what do we have to do? Our first step was to initialize all of them. 1 equals to 0, 2 is equals to 0, and common. Now for entire going from 0 up till the end of the array, I press plus. Our first step was to update our 2. 2 equals to 2 XOR 1 and ARR of I. 1 would become 1 XOR of ARR of I, the new element. Then our common would become 1 and 2. Then our 1 would become 1 and with tilde of common, and as well as 2 would become 2 and with tilde of common. Okay. At last return. This was our whole code. Let's see if it is running fine or we have committed any mistake in the typing. Running fine for the compile and run. Let's try it for submit also. Running fine. As you can see, we have completed a 20-day streak, and it was all because of your love and support. Keep supporting me, and if you have any questions, don't hesitate to ask. Also, I'm attaching my link to the Discord server. Please make sure you join for the regular updates. Thank you. Have a nice day. I am sure a happy and safe journey is following your way. Okay, bye. Have a nice day.